Hey, what's up guys? This video is for section 2-4 solving equations with variables on each side, and this is the second video, part 2 of this section. If you guys need to watch part 1, go ahead and go back and look for that video, but this one is when you guys want to solve with fractions in the equation and you guys have to distribute and you have to combine like terms. Now before we actually do some examples, I do want to go over the steps that I like to use when I solve an equation. And so let's go ahead and review those 3 steps that I like to follow when I want to solve an equation. Step number 1, we want to simplify each side of the equation and get out the variables on the same side. What do we have to do? Well, maybe we're going to have to use the distributive property. Maybe we're going to have to combine like terms. Maybe we're going to have to cancel fractions, and maybe we have to get all the variables on the same side. Now for this video, we are going to do all that so you guys know how to simplify each side of the equation. After you guys finish that step, you guys move on to step number 2. Step number 2 is you eliminate the constants on the same side of the variable. And to eliminate the constants, which is the number with no variable, you guys are going to use the inverse operations for adding and subtracting. So you guys do the opposite. After you guys finish step 2, you move on to step number 3 to isolate the variable, which means you have to get that letter or that variable by itself. So we can use inverse operations for multiplication or for multiplying and dividing or division. You guys need to do the opposite to get that x or the y or whatever variable you guys have by itself. So if you guys look at these examples here, we have fractions, we have parentheses, and we want to solve for the variable. So I just want you guys to notice the difference between these equations and how the fractions might look like when you guys want to solve. But let's go ahead and start with the one on the left side here. So notice that we do have a fraction outside of the parentheses. So I am going to distribute this 1/2 to the inside of the parentheses. We're multiplying 1/2 times the quantity of 5 minus 2h. And on the other side, we also have a fraction, but it doesn't have parentheses. We have h over 2. So first, let's go ahead and distribute that 1/2 to the parentheses. So I'm going to multiply all of this times the number inside. Now, if you guys don't remember how to multiply that fraction times the number, well, all you have to do is you multiply the top number, the numerator, times the inside, and you guys keep the denominator. And that's because you can convert this 5 into a fraction. You can put a 1 under the 5, and notice when you multiply the top numbers. That's going to be 5, and I'm just going to put that here so you guys can see it, over, and on the bottom is going to be 2. 2 times 1 is 2. So that's why I say you multiply the top numbers, the numerators, and you guys keep the denominator. 2 times 1 is going to be just itself. Then you guys multiply the next one. So you are going to distribute that 1/2 times the minus 2h. Now remember, we multiplied the numerator times the number inside, or the term in this case, minus 2h. So that's going to be negative minus 2h. One more time, you multiply the 1 times the 2h. So that's going to be 2h. And you guys keep the denominator. So we have over 2. That's how you distribute the fraction into the parentheses. On the other side, you guys will have h over 2. Now, you do have fractions. So the next step is to get rid of the fractions. One thing that you guys notice or might notice is this one here, this fraction. You guys can actually simplify to 1. 2 divided by 2 is 1. But let me give you guys a hint, or let me give you guys a tip, not a hint, a tip. You guys don't have to reduce the fraction because eventually you want to get rid of the fraction. So instead of reducing the fraction, notice that all the denominators are the same. So that means that to cancel the fractions, you can multiply by that denominator. They're all the same number, so you multiply by 2. So I'm going to multiply this fraction by 2. this fraction by 2 and this one by 2. Now remember that when you multiply fractions, you can also cross simplify. So you can cross simplify this 2 down here and these 2 up here. They simplify to 1. So just keep the 5. So one more time, you guys can cross simplify the 2 here, the 2 over here. 2 goes into 2 one time. You can actually put a 1 here. You don't need to, but if you multiply 1 times 5, so that's going to be 5. The next one, we have a 2 on the bottom, and you guys can simplify the 2 that you're multiplying. So you can cross simplify this one, and we have a minus 2h. Remember that you have to check the signs. We do have a minus here, and these 2 simplify to 1. They cross out, so you guys keep the 2h. On the other side, we have equals here. You guys can cross simplify this one and this one here. So all we have left is the h. Well, guess what, guys? We don't have any more fractions. We don't have parentheses, but we do have variables on each side. So now you guys are going to look for the lowest variable, and negative 2h is the smallest one, smaller than 1h. We have an invisible one here. So you guys are going to do the opposite of the minus 2h. So I am going to add 2h here. And when you guys add 2h, on the left side, well, these 2 cancels. You bring down the 5. On the right side, we have 3h. The next step, you want to isolate the variable. So I want to get rid of the 3. So I'm going to divide by 3 here. Divide by 3. So my answer, notice the fraction right here, 5 over 3. That one doesn't simplify. So I'm going to keep it as 5 over 3. I bring down the equal sign. And right here, 3 divided by 3, that becomes 1. We don't need it, so you put h. So my answer is 5 over 3 equals h. Or you can say h equals 5 over 3. So let's try this one here, where the fractions are different on the left side and the right side. Notice we have a 1/3 on this side. We have a 1/6 on the other side. So what I like to do is I like to distribute the fraction into the parentheses. So I am going to multiply this 1/2 times the n, and we do have a 1 next to the n right here. So remember to multiply the numerator times the term inside. 1 times 1n, that's just 1n. So I'm going to put 1n and keep the denominator. And then you guys multiply 1/3 times the next one. So 1 times 1 is 1 plus 1 and keep the denominator. So this one here stays the same. On the other side, let me put the equal sign right here. You guys are going to distribute the 1 over 6 times the 3 over n. So I'm going to multiply the top, the numerator, times the inside. So that's going to be 3n. And you keep the denominator. And then you guys are going to distribute the 1/6 over -5. You multiply by -5. So you multiply the numerator times the -5. So that's going to be -5. And you guys keep the denominator. The denominator is 6. So that one stays the same. One more time. Notice that we do have 3 over 2 here. You guys can reduce the fraction, but you don't have to, because eventually we want to get rid of the fraction. So the easiest thing to do right now is to multiply by the lowest common denominator. And I'm saying the lowest common denominator because the denominators are not the same. There's a 3 and a 6. So the lowest common denominator is 6. So you guys are going to multiply this by 6, this one by 6, this one by 6, and this one by 6. Remember that in an equation, whatever you do to one side, you have to do to the other side to keep that balance. And to get rid of the fractions, just multiply by the denominator, or if you guys have different denominators, multiply by the lowest common denominator. And I'm going to write that down So you guys remember that we are multiplying by the LCD, the lowest common denominator, which is 6. So let's go ahead and cross simplify. Going back to the beginning right here, this denominator, 3 simplifies with the 6 by 2. So 3 goes into 6 2 times. I'm going to multiply 1n times 2, and that's going to be 2n. Then you guys cross simplify the 3 and the 6 again, and that's 2. 3 goes into 6 2 times, and you multiply 1 times 2 is 2. So I'm going to have plus 2. On the other side, you cross simplify the 6 with the 6. So 6 goes into 6 one time, and 3 times 1, or 3n times 1, that's going to be 3n. And the next one, 6 simplifies with the 6 one time, and 5 times 1 is 5. But we do have a minus. There's the minus here, so you bring down the minus. 5 times 1 is 5. We don't have more fractions. We don't have parentheses. These are not like terms. These ones are not like terms. So the only thing we can do now is get the variables on the same side. So the smallest variable is 2n. There's a 3n here, 2n over here. So I like to do the opposite of the smallest variable. So I'm going to subtract 2n from both sides. And when I subtract, this cancels. So there's a positive 2. Over here, 3n minus 2n, that's going to be 1n. I don't need that 1 next to the n. And then you guys bring down the minus 5. Now you guys eliminate the constants on the same side of the variable. So there's a minus 5 next to it. So I'm going to do the opposite of that. Plus 5 over here. Let me just bring down the line here. And you add 2 plus 5, that's 7. Bring down the equals. There's the n. You can cross out the negative 5 plus 5. So that's my answer. Notice we have n by itself. There's no negative next to it. There's no number next to it other than 1. There's an invisible 1. But 1 is okay. We just don't want anything else other than 1. So my answer is 7 equals n. Or using symmetric property, you guys can say n equals 7. Now this one here, there's no parentheses, so you're not going to distribute any fractions or numbers into the parentheses, but we do have fractions. And all the denominators right here, guys, are not the same. There's a 2, 8, 8, and 2. So the easiest way to cancel the fractions, you want to multiply by the lowest common denominator. And the lowest common denominator, LCD, is 8. Because 2 goes into 8. 8 goes into 8 one time. So we can actually multiply by 8. And that's the lowest number that we can use. So I'm going to multiply this one by 8. This one by 8. This one by 8. And this one by 8. Every single fraction, every single term, you multiply by the lowest common denominator. So let me bring down the line here. I'm going to cross simplify. Let's go back to the beginning. 2 goes into 8 4 times. So you multiply 1 times 4, and that's going to be 4. The next one is 8 goes into 8 one time. You don't need to put that 1, but you just, I have it so you guys can see it. And we have a minus 5, negative 5 times 1. So that's going to be negative 5. And we do have an x, minus 5x. You just bring down the variable. Then you guys cross simplify the 8 and the 8 right there. So all we have left is the 7x. 8 goes into 8 one time. So we just bring down the 7. And over here, 2 goes into 8 4 times. So you multiply positive 7 times 4. So that's positive 28. We do have variables on each side. So I'm going to look for the lowest one, and that's, or the smallest one. The smallest one of the x's is negative 5x. This one's positive 7x. So the smallest one is negative 5. So I'm going to add 5x to both sides plus 5x here. And you guys can cancel the negative 5x plus 5. So you bring down the 4, and on the other side, you guys combine 7x plus 5x, and that's going to be 12x, and you bring down the plus 28. Now you guys go to step number 2. We don't have any more fractions. The variables are on the same side. We don't have like terms, so we can move on to step number 2. You guys eliminate the constants on the same side of the variable, which is this one. There's a variable, so this is the constant. So I am going to do the opposite, minus 28, and you guys on the other side subtract 28, so we get negative 24 on the left side, and on the right side we get a 12x. So now you guys are going to isolate, this is the number 3, isolate the variable. So I am going to divide by 12, and when you guys divide by 12, we get negative 2 on the left side equals, and this one turns into 1, we don't need it, x. Or you guys can say x equals negative 2. Now remember that the variable doesn't matter where you guys have it. You guys can have the variable on the right side of the line or the equal sign. You guys can have an x on the left side. Just as long as you guys have an x on one side, and then you start solving using the steps, you guys are going to get the same answer. Just make sure you guys check your signs and always follow the steps to solve. Now, one of the things that can happen when you solve an equation is the variables cancel. So you guys don't have any more variables. When that happens, we say those are special cases. So let me explain what the special cases are. There's 2 special cases that you need to understand. Number 1 is called the identity. An identity is an equation, so we have an equal sign, that is true for all values of the variable. An equation that is an identity, so it is true for all values, has infinitely many solutions, or you can also say all real numbers. Now let me show you guys what that means. Imagine that you guys are solving an equation, the variables cancel, so there's no more x, there's no more y, the m became 0, the variables cancel, and you have an equation. So let's say we have equals here, and there's a negative 3 on the left side, and there's a negative 3 on the right side. Well, that equation is saying that this number is equal to this number. And that's true. Negative 3 is the same as negative 3. So this one is a true statement. That's what we say. The equation is a true statement. So when that happens, guys, your answer will be either infinitely many solutions, you can write that down, or you need to write down all real numbers. Now we do have a symbol that we can use for all real numbers, which looks like an R. But when you guys see that R, that means that the variables cancel, but the equation, the statement is true. So I'm just going to put that here, the R, because this equation that I show you guys, negative 3 equals negative 3, well, that's true. So we can say all real numbers is my answer. Now, another case that you might have is when the equations are always false. So that means that the equal sign, the equation, the statement will be false. And these equations have no solution. So let me show you guys an example of that. So let's say you guys have an equal sign, the variables cancel, and you guys have a 2 equals negative 3. Now that's false, because the two numbers, the 2 is not the same as negative 3. They're not the same value. They're not the same number. So when that happens, you guys are going to write no solution, or we have a symbol that we can use, which is a circle with a line going through it. That circle, this one here, means no solution. So we don't have an answer. When the statement is false, we do not have a value of the variable. There's no solution. When the statement is true, all real numbers, what that means is any number actually works for the variable. So any number that you can think of is the answer for that variable. And it might be an x, it might be a y, it might be a p. But any variable that you guys use, all real number means that every number is an answer. And those are the special cases that you guys need to be aware. So let's go ahead and look at two examples and identify which special case it is. Now, just looking by the equations, you guys don't really know which one is a no solution or a many solutions, or you can say all real numbers answer. So you just have to work, you have to start solving for that equation and see what happens. So I'm going to show you guys the one on the left side first. We don't have fractions, but we do have parentheses. So I am going to, first of all, distribute that 4. So I'm going to multiply 4 times 3. Let me just bring down the line under the equal sign. 4 times 3 is 12. And then I'm going to multiply 4 times positive 2q. And that's going to be positive 8. 4 times 2 is 8q. On the left side, these are not like terms. So let me just bring down the 8q plus 12. Now I'm going to get the variables on the same side. So I'm going to subtract 8q and subtract 8q. Now notice what happens here. The 8q cancels right here, and the 8q minus 8q also cancels on the right side. So what we have left is a positive 12 on the left side, there's the equal sign, and a positive 12 on the right side. Guess what? That statement is true. 12 equals 12, they're the same number. So what we say, my answer is all real numbers, or you can say infinitely many solutions. I'm going to put all real numbers here. Either one, I'm okay. Also, you can use the symbol. All real numbers is an R. I just do 2 vertical lines like this, and I start making my R. So that symbol means all real numbers. So any number that you can think of is an answer for Q. If you guys substitute any number into this variable, the statement is going to be true. So you can substitute a -3. You guys can substitute a positive 1/2. You guys can substitute any number, and it's a true statement. Now this one here, you guys have fractions. We don't have parentheses, but let's go ahead and get rid of the fractions, and then we can start solving for the equation. So the denominators, both of them are the same number, 2, 2. So I'm going to multiply everything by the denominator. I don't need to find the lowest common denominator because they're already the same. So I'm going to multiply by 2, which is the denominator. So this one you multiply by 2. This one you multiply by 2. The 3 you multiply by 2. And this fraction you multiply by 2. Let's go ahead and cross simplify. 2 goes into 2 one time. So we just bring the 5. 1 times 5 is 5. There's a 5x. You guys multiply negative. There's a minus x times 2. Remember that x has an invisible 1. So we are going to multiply -1 times 2. That's -2x. Here's the line under the equal sign. On the other side, I'm going to multiply 3 times 2. So that's going to be 6. And the next one, you guys cross simplify. 2 goes into 2 one time. So you just bring down the 3 plus 3 with the x. No more fractions. We do have variables on each side. So let's go ahead and get the variables on one side. Something else I noticed is that we also have like terms on this side. So I'm going to combine those two before I get the variables on the same side. These are like terms, and they're on the same side of the equation, so you guys can combine. 5x minus 2x, that's 3x. And on the other side, I have a 6 plus a 3x. Now, these are not like terms, but we do have variables on each side. So let's go ahead and do the opposite. Now, they're the same variables, so it doesn't matter which one you guys do the opposite. I'm going to subtract 3x here, subtract 3x over here. So let's pay attention and understand the problem. First of all, over here, the 3x minus 3x on the left side, they cancel. Now think about it. When you guys cancel something, 3x minus 3x, that equals 0. So since we don't have anything else on the left side, we actually have to write down 0 because that is what happened. 3x minus 3x, it equals 0. On the other side, well, we don't have 0. These do cancel, but we have something else. We have a 6 on the right side. So instead of putting 0, I just bring down the 6. So no more variables, but the equation, what we have is 0, bring down the equal sign to 6. Notice, that is false. And since it's false, we have no solution. So I can use the symbol, and I'm just going to use the symbol here, a circle, and you guys just cross it out. That symbol means that we do not have an answer. There is no solution. So let me write down here, no solution. So you guys know that the symbol means there's no answer. So be careful with those special cases. Sometimes you guys will have an answer like x equals 1, y equals -5. Or sometimes we might have special cases where the variables cancel and you have to make sure if the answer is no solution or many solution. Alright guys, so this concludes my video, my second part of this section, which is solving equations with variables on each side. If you guys like my videos, make sure you guys hit that like button. You can also subscribe to my channel. And I want you guys to practice your math, and I'll see you guys later.